Hello my dear friends, colleagues and students. On the behalf of ASSMS IOIT ANTC department, I welcome you all again in today's session where we will see the lab tutorial assignment number 2. In last session, we discussed on this tutorial assignment based on KVL, and in today's session, we will do this on tutorial assignment based on node analysis. So the problem statement which given is seen in the figure, where you have to find out the node voltages in the given circuit. Before going to start or before going to proceed, we required some prerequisite. What is mean by node analysis? This method is totally depends on Kirchhoff's current law. In this method, also minimum number of equations need to be written to determine the unknown quantities. This method is particularly suitable for network having many parallel circuit with common grounds. For application of this method, every junction in the network where two or more elements meets is considered as a node. One of these is considered as a reference node or zero potential node. Hence, number of simultaneous equations to be solved becomes n minus 1. So from this figure, you should able to know how many number of nodes are present in this circuit. So as per calculation, this is the first node, this one is the second node, and this one is the third node. This is the fourth node, which is also called as a reference node. This is also called as a reference node. Now we have to solve this numerical using this node analysis. Okay, again we can redraw the same circuit of node and redraw the given circuit as like shown in figure B. Okay, next, now we have to write the KCL equation for node 1, KCL equation for node 2, and KCL equation for node 3, because as we know there are total nodes are 4. Among them one is the reference node. That means number of equations you have to write becomes n minus 1 is nothing but 4 minus 1 is nothing but the 3. These 3 KCL equations we have written, and now after solving these equations by using either matrix form or Cramer's rule, we will get value of V1 5.412, then value of V2 it is 7.736, and value of V3 it is 0.31 it is 46.32. So these three values we are getting after calculating or after solving these three simultaneous equations by either Cramer's rule or by using that matrix form one and same. Okay, so now we are getting these three voltages where we have to find out V1, V2 and V3. We have the answers. Now we can cross check these answers by implementing the same circuit on www.falstad.com. So once again, please see or look out the circuit carefully. Here 5 resistances and 3 current sources are present. So a series parallel combination is there. So V1, V2 and V3, one reference node. So the same circuit we have to draw on falstad.com, that we will do in next. Okay, so proceeding towards falstad.com, just a minute. Now we can rebuild or we can implement the same circuit on falstad.com in a simple way. So try to understand. First you have to remove this circuit which is already present in this falstad.com, okay, or in this circuit simulator applet. So first delete this circuit. Now you have to draw the same circuit where you required 5 resistances. Okay, so 5 resistors. So I'll put first all resistors, where in the same manner I'll try to draw where the number of resistors was there in this according to their position in the circuit. So these are the third one, this is the fourth one, and this is the last fifth one resistor which we required in the circuit. Now press escape. After this we required 3 current sources. Okay, so the draw 3 current sources. Go to the input sources, you will get add current source. Okay, now depending upon their directions you can just click and you can draw this current sources. So one is in parallel with of that 5 that resistance, and the next one is in parallel with this resistance. Okay, so it will be in this direction. Yes, now press escape and complete the circuit diagram. Add wires. So again I'll try to complete the circuit diagram. Before this I have to change its values also. So this is a current source of -8 ampere, -8, apply OK. This is of -25, again -25 is the ampere. Okay, -25, so apply OK. And this one is of -3 ampere. Okay, so just -3 ampere as it is inbuilt they have given. Now this is the resistance of 4 ohm, not 1k, so it will be 4 ohm, apply OK. This one is of 3 ohm, okay, 3 ohm, apply OK. This is of 7 ohm, 7 ohm, apply OK. And the last one is of 5 ohm, 5, apply OK. Okay, so all values are set now. Now we have to complete this circuit so that we can find out the voltage across these V1, V2 and V33 potentials. So when your circuit connections is correct, the color of this circuit goes on changing. So complete the implementation of circuit in a proper way. Yes, then this 3 ampere will be in parallel with this 3 ohm. Yes, and the last one, this 4 ohm, is present in between node 1 and node 3. So I'll connect it directly to node 3. This one is the node 3. Yes, we have completed the circuit diagram, but this is node analysis. Node 1 will be over here, node 2 will be over here, node 3 will be over here, but most important is node 4, which is a reference node. Now here we required a passive inputs, add ground, and we have to put ground also for this zero potential, this because this is a reference node. Okay, now see, now we can cross check the final answers. So voltage across the node 1, it is 59.06. just a minute, I think somewhere, yes, the value of this resistance will remain same. Okay, so it is not 1k, it is 1 ohm only. Okay, so apply OK. Yes, I forgot to change the value of that resistance. Okay, now check the voltage at position 1 or V1. Okay, node 1, V is equal to 5.414. it is exactly same as we have calculated in theoretically. V2 is nothing but 7.73, again exactly same value. And V1, V2 7.7 and V3 it is 46.316. so this is the exact same answers which we are getting while solving this numerical theoretically. Okay, you can cross check over here. See here, V1 5.412, V2 7.736, V3 46.32. okay, so same thing, same results you are getting over here. So V1, V2 and V3. Okay, so this is the implementation of node analysis, or implementation of the circuit, or finding out the voltage across any node by using node analysis method. Thank you all.